Hi students, let us continue the next problem on the maxima and minima. Find the two positive numbers whose sum is 16 and the sum of whose cubes is minimum. This type of problem we have already solved in the previous video. Here the two positive numbers are there. The sum of those two positive numbers is 16 and whose the sum is 16 and the sum of whose cubes is minimum. So I just consider first of all let the positive numbers are, let x and y are the two positive numbers. X and y are the two positive numbers. Then we have given that already their sum is 16. Therefore x plus y is equal to how much? 16. And the sum of whose cubes is minimum. Sum as well as cubes we need to take. Sum as well as cubes, that is x cube plus y cube. Sum of whose cubes is minimum. We have to take the cube and we have to take the sum. Word is very clear. The sum of whose cubes. Sum of cubes. Sum of cubes of the two numbers. Okay. This function we have to make it as a minimum. A function is a minimum. Once again, this is a given function. I just denote instead of e of s is nothing but sum. So here already given x plus y is equal to 16. Either write this function only in terms of x or only in terms of y. Nothing but I just replace y value. I am just going to write in terms of x. So using this one, what we can write? S of x is equal to what? X cube plus in place of y. What is the y value? 16 minus x is 16 minus of x whole cube. So I just write here s of x is equal to x cube plus 16 minus x whole cube. Here we can expand it a minus b whole cube, then differentiate, we will get it, or else as usual. So already you know that differentiation, several types of the differentiation, composite function differentiation is that directly differentiate. Don't waste your time to expand it. If you are not convinced with this one, you can expand it. A minus b whole cube, a cube minus 3a square b plus 3ab square minus b cube, in that manner. Okay, now I just differentiating this with respect to s. S dash of x is equal to, what is the s dash of x? 3x square. This is a plus x cube form, 3 into 16 minus x whole power 2. Here in place of x, 16 minus x is that. Again differentiation of 16 minus x is what? 16 minus x differentiation is 0 minus 1. So here I just write it as a minus. Now, so we have to use the second derivative test. So I just differentiate one more time, or again differentiating s double dash of x is equal, what is that? 3 to 6 x minus 3 to 6 into 16 minus x per differentiation is over 2x. In place of x, 16 minus x, differentiation of 16 minus x is minus 1, minus into minus plus. Now here this is the equation number 1 and this is equation number 2, this is the equation number 3. What I just do means, suppose we are required to find that critical point. Suppose s dash of x is equal to 0. If the s dash of x is equal to 0, what will get s dash of x? Call this as equation number 2. Suppose s dash of x is equal to 0. What happens? 3 times of x square minus 3 into 16 minus x whole square is equal to 0. Shifting the terms. 3 into x square is equal to 3 into 16 minus x whole square. Here 3 get cancelled. Here also square is that I am just taking the square root on both sides or raising the power 1 by 2. So here raising the power 1 by 2, that will get x is equal to 16 minus x. If I raise the power 1 by 2, both will cancel. Actually we need to write the plus or minus, square root is that, but here only positive numbers are there. Positive number square root is again a positive number. So that minus x is that, shifted into left hand side, plus x plus x 2x is equal to 16, x is equal to 8. If x is 8, what will be the one? If x is 8, this equation number 1 implies, therefore equation number 1 implies y is equal to 8. x is equal to 8 as well as y is equal to 8. X and y values will get it. How about it? Now, after getting the x and y, is that satisfy the condition? Sum is 16. Okay, sum is 16, no problem. And the second condition is that sum of whose cubes is minimum. We don't know, so we cannot say that directly. That's why we have to say that this equation star has to maximize. How to? Here is minimize is that how to minimize. How to minimize it? So I am just going to use that by the second derivative test. So by the second derivative test, what happens? What is the second derivative test says? If f dash of x is equal to 0, then f double dash of x, or else f dash of c is equal to 0, then f double dash of c is negative, then the c is the point of local maximum. If f double dash of c is positive, then c is the point of local minimum. So that reason I am just telling that by the second derivative test. What we can say that I'm just going to check the f dash of x is already 0, that is s dash of x is equal to 0 is that. So s double dash of x, s double dash of x at x is equal to 8 and y is equal to 8. X and y are both are 8. So s double dash of x at x comma y is equal to 8 comma 8. Where is the s double dash of x? Here is our s double dash of x. So what we get? 6 into 8. 6 into 8 plus 6 into 16 minus 8 is 8. So simplifying, what will get? 6 into 8 plus 6 into 8. Both are positive. So it is obviously the positive. We don't need the final value. We just need whether it is a positive or negative. We can simplify. Simple number is that, no doubt at all. So we can save the time. Okay, now it is a positive. It is a positive means what we can say that by the second derivative test. So x is equal to 8 is the point of s is equal to 8 is the point of local maximum or local minimum. It is the local minimum. Therefore, what we need to show that. So find the two positive number whose sum is 16 and sum of whose cubes is minimum. Sum of whose cubes is, we just got the same function as the minimum. Therefore, s of x is the minimum at x is equal to 8 and y is equal to 8. Therefore, the required positive numbers are two positive numbers are. What are the required two positive numbers? That is 8 and 8. X is equal to 8 as well as y is equal to 8. Hence the solution. This type of problems are very important for the examination point. They might have asked for the 3 marks session. Okay, now let's move to the next example. Yes. A square piece of tin of size 18 cm is to be made into a box without top. By cutting a square from each corner and folding up the flaps to form the box. What should be the side of the square to be cut off so that the volume of the box is maximum as possible? Okay, yeah. Read the sentence. Read the word. It is simply a word column. So read the words very carefully. So there is a square piece of tin is there. A square piece of tin is there. Suppose a square piece of tin. This is the square plate is there. This square piece of tin of side is 18 centimeter. 18 centimeter side length. Each square is that means all the sides have the equal in length. This length is 18 centimeter. 18 centimeters. This square piece is going to make a box. How? Without a top. Is to be made into a box without a top. Without a top, we have to make it as a box. Okay. How we have to make this as a box means by cutting a square from each corner and folding up the flaps. How to make this square tin plate as a box means we have to cut the square pieces from each corner. How many corners are there? 4 corners are there. From each 4 corner we have to cut a square piece, and after cutting the square piece we have to fold the flaps. Remaining flaps you have to fold it to form a box without a top. Then I think you have got the imagination. Okay. What should be the side of the square to be cut so that the volume of the box is maximum as possible? For example, we have to cut the square piece of from each corner. So from each corner, I am just going to cut the square pieces. I just take this as a x centimeter is going to cut. Here already 18 centimeter side length is there of the thin piece. Out of that 18 centimeter, I am just going to cut one corner side length as a x. This is also should be the square x. Here also it is x like that. In all the four corners, we have to cut the square pieces from each four corner. The remaining flaps, these flaps are there. We have to fold and we have to make it as a box without a top. For example, here a square piece is there. For this square piece, we have to cut from each corners plus again a square pieces, and we have to make it as a without a top a box. How we can make it as means, here a square piece is there. From each corner, I am just going to cut the square pieces. From each corner, I am just going to cut the square pieces. After cutting the square pieces, the flaps are there. So here it is a square piece is there. This is square piece, and just cut from each corner a square, again a square. Then the flaps are left. So those flaps we have to fold and we have to make it as a box. Okay, these flaps I just fold that and we have to make it as a box. This is a box without a top. How? So observe that here it is a square piece. From each corner I have already cut the square of the x. That side of the square piece is x centimeter. Then we have to fold these are the flaps. So these flaps folding, we have to make it as a box. We have to make it as a box. On making folding the flaps, we get a box. So this box should be get a volume of the box is maximum as possible. Volume of this box should be maximum. Then so that how much length we have to cut from each corner out of the 18 centimeter. It is the question. I think you got the meaning of the question. Okay, now here I just begin the solution. What is the solution means? I just consider that let x unit or x centimeter length is going to cut from each corners of the square piece. Each corner of the square piece of thing. This is the x unit I am just going to cut. Then what is the length? So this is the box is there. Then what is the side length of the box? What is the side length guys? Here also x unit, here also x unit. Total length is 18 centimeter is there. So here this remaining side length. What is this remaining side length? This side length is 18 minus of x. That means 18 minus 2x is the side length of the box. Can you people agree? X unit one corner, x unit one corner. This is the corner of the piece. Here this side x unit length, this side x unit length, a square piece is cut. Then the remaining side length of this one is 18 minus 2x. So that this is 18 minus 2x. This is x unit, this is x unit. Now box is becomes a only this is the box. This is having this side length as a 18 minus 2x. We know that what is the volume of the box? Length into breadth into height. Volume of the box is length into breadth into height. So here what is the length? So here length is equal to length of the box is 18 minus 2x. Length of the box is 18. Length. What is the breadth? Breadth is again same thing, 18 minus 2x. Can you agree? This is the length, this is the breadth. If you cut here a square, again it becomes a square only. Okay. 18 minus 2x is the length as well as the breadth. What is the height? What is this height? This height, can I say that x unit, because this is a flap. The flap is going, flap has already cut the x centimeter, so that height of the box is x unit. This corner piece is that clear? This flap is that is our required height of the box. Now we can proceed it. Now how do we proceed? Length is 18 minus 2x, breadth is 18 minus 2x, height of the box is x. So volume is equal to, what is volume? Length, breadth, height. Length, breadth both are same. So 18 minus 2x, 18 minus 2x. That we can write 18 minus 2x whole square into height. Height is x. So this is the value. This function we have to make it as a maximize or minimize. We have to make it as a maximum. So what is the length we have to cut at the corner to become a volume of the open box is maximum. So this function, it is sufficient to maximize. That's all. So volume in terms of only x is that variable. This function maximizes. Use a second derivative test, you will get the required answer. So I think you have got the meaning of the question. Once again you can cross verify. The square piece of pin of side 18 cm is to be made a open box into a box without the top, open box, by cutting a square from each corners and holding up the flaps to form a box. Okay, we have to cut the square from each corners. Each corner I have just cutted the square to make the box. These are the flaps are left holding to get the box. Then so each corner of the flaps to box. What should be the side of the square to be cut? What should be the side of the square to be cut so that the volume of the box is maximum? So that the volume of the box is maximum. Okay. So volume we have to make it as a maximum. So differentiating with respect to x. What is that? 3 dash of x is equal to product to 2 into 18 minus 2x whole power on x square. Differentiation is over. Now in place of x, 18 minus 2x, differentiation of 18 minus 2x, 0 minus 2. 2 already is there, minus 2 into 2, it is minus 4, or better right, here it is a minus 2 into second function as this. First function as this, 18 minus 2x whole square, x differentiation is 1 into 1. Again I am just going to rewrite, 3 dash of x is equal to 2 into minus 2, minus 4 into x into 18 minus 2x. This x I just written here. And here plus 18 minus 2x whole square is there. Okay. So we can call this as equation number 2. Now again differentiating with respect to x. What we get? P double dash of x is equal to. Here again a product minus 4 is common for this first function. X differentiation is 1. 18 minus 2x as it is. Plus x as it is into 18 minus 2x differentiation is minus 2. Okay, minus 4 is product with only these two terms. Plus as it is 18 minus 2x whole square differentiation is 2 into 18 minus 2x whole power 1 into 18 minus 2x differentiation is minus 2. I just rewrite p double dash of x is equal to minus 4 into this bracket. What will get? Minus 4 into, first of all, simplify the bracket. Here minus 2 into x, minus 2x minus 2x, that means minus 4 times of x, plus 2 into minus 2, that means minus 4 into 18 minus 2x. Now I just continue here. What we get? 3 double dash of x is equal to 3 double dash of x is equal to minus 4 minus 4. I just take the minus 4 is common. If I take a minus 4 is common, what is left? 18 minus 4x. Minus 4 is already common, plus 18 minus 2x is there. Okay, I just written minus 4 is common. This minus 4 is outside. Minus 4. Here 18 minus 4x. Minus is outside, so that it is a plus. Plus into 18 minus 2x. Yes. Again simplifying. P double dash of x is equal to minus 4 outside. 18 plus 18, that means 36 minus 4x minus 2x minus 6x. Okay. Again, is anything common? 6 is common. 6 if you taken, already minus outside. 4, 24 into 6 minus x. This is the P double dash of x. This is the P double dash of x. Call this as the continuous equation number 3. Now, I am just going to find that critical point. I am just going to use the second derivative so that find the critical point. How to find the critical point? Suppose first derivative P dash of x is equal to 0. If P dash of x is equal to 0, where is the P dash of x? Equation number 2. So, what is the P dash of x? Minus 4x into 18 minus 2x plus 18 minus 2x whole square is equal to 0. Now, simplify this one to find the x value. So, I just write plus 4x into 18 minus 2x is equal to 18 minus 2x whole square. Or else apart from this, we can take a common and simplify better. So, we will get the easily answer. So, out of these two terms, what is the common? 18 minus 2x is the common remaining term. Minus 4x is left. 18 minus 2x is already outside. So, here one of the 18 minus 2x is outside. Remaining term is 18 minus 2x. 18 minus 2x as it is, which means that I am just doing the factorization. That's all. Minus 4x minus 6x. That means minus 4x minus 2x is a minus 6x is equal to 0. 18 minus 2x into 18 minus 6x is that. I just take 6 is common. What is that? 3 minus x is equal to 0. Now we can easily find the x value. Factorized form is that. So 6 is never becomes a 0. Either 18 minus 2x is 0 or 3 minus x is 0. This implies x is equal to. So minus 2x is equal to 8 minus 18. So 2 ones are 2 9s are. Either x is 9 or x is equal to 3. X is equal to 9 or x is equal to 3. Okay. So here two values this is called. X is equal to 3 or x is equal to 9. Both are possible. Okay. What happens if I replace x is equal to 9 in the value? What will we get? 2 into 9. 2 into 9, 18. 18 minus 18, 0. So 0 square 0 into 9, 0. So value becomes 0, which is not possible. So that x is equal to 9 is not possible. Why it is not possible? I have already given the clarification. Why the x is equal to 9 is not possible means at x is equal to 9, value becomes a 0, which is not possible to cut out of the 18 centimeter as a 9 centimeter. If you cut the 9 centimeter out of the side length as a 18, that is exactly 9 is a middle. We can hold it. If you cut this one, will not get any flaps. Are you clear? So that reason which is not possible to take x is equal to 9. The only thing possible value is x is equal to 3. So at x is equal to 3, what is the equation number 3 implies? What is the equation number 3 implies? That means I am just going to use that by the second derivative test. What is the p double dash of x at x is equal to 3? So minus 24 into 6 minus 3 is 3. So is positive or negative? It is a negative. No need to multiply. Just try it. Positive or negative. Okay. It is a negative quantity. So that means x is equal to 3 is the point of maxima or minimum. Second derivative is negative. So it is the point of maximum. It is the point of maximum. Therefore value is maximum. Value is maximum when x is equal to, or lim is maximum if the corner square piece should be cut into 3 centimeter. If the corner of the square thin piece is going to cut 3 centimeter, then in that case we'll get the maximum volume of the box. Volume of the box will be maximum whenever x is equal to 3 centimeter. If you cut 4 centimeter, in this case will not get the volume is maximum. If you supposed to cut 5 centimeter, in this case, which is not possible to get the value is maximum. When we get the value is maximum, whenever the square piece has to be cut as a 3 centimeter. This is the proper result. This is the application, one of the application of the derivative. So like that, in a daily life, we are going to use this type of product. For example, you can have where you want to apply this one. Suppose you want to make, or you are supposed to doing the or constructing the one building. You have to make one water tank under the ground. So underground water tank you supposed to do means, in that case this type of application is going to use. Using that, what is the length, breadth, height of the tank to get the maximum value. We can store in the maximum number of liters of the water into that tanker. Then in such cases we are going to use this type of here analyze data is that we have just got the required result. Now this type of problems are very important. So now let's move to the next example. Show that of all the rectangles inscribed in a given fixed circle, the square has the maximum area. Okay. Fixed circle is that, suppose the circle has the fixed, that means radius of the circle is constant. Suppose the fixed circle is that, in this fixed circle rectangles are there. How many rectangles we can draw on inside the given circle? There are many number of rectangles we can draw. Okay, this is one of the rectangle, and already you just know the properties. Suppose we can name this for rectangle as a ABC is a rectangle. This is one rectangle. We can draw one more rectangle, and again and again. There are so many rectangles you can draw. Okay, so out of these infinite number of rectangles, out of these all infinite number of rectangles, the area is maximum. Which rectangle area is maximum? Square has the maximum area. Square is also one rectangle. So that particular case is that. So that out of all the rectangle, square has the maximum area. That one we have to prove. Property. What is the property? We have just know that a diagonal of the rectangle is passes through the center of the circle. Diagonal of the rectangle is passes through the center of the circle. Are you clear? Already know this property. Okay. Diagonal is passes through the center of the circle. I just rub this name of the rectangle. You know, C is the center. Okay, R is C. C is the center of the circle. R is the radius of the circle. Then I just consider length of the rectangle as x and breadth of the rectangle as a y. Length is x in it, breadth is y in it, and radius is r in it. We have to prove that it has the maximum area. How do you find that? We just know that. So better to write. Let r is the radius of the circle. R is the radius of the circle, because we are not given any values, so we have to assume it. So we have to give the numerical values. Okay. We have to give the standard values or standard notation. Next, x is the length of the rectangle. Length of the rectangle is x. Y is the breadth of the rectangle. Now we know the area of the rectangle. What is the area of the rectangle? Length into breadth is the required area of the rectangle. Here area is in terms of the two variables. Whether x and y are the variables? Yes, obviously it is a variable. Side length is varying, breadth is varying, length is varying, as well as breadth is varying because different rectangles are there. So that convert this area into a single variable. Convert this area either in terms of x or in terms of y. How do you replace x in terms of y or y in terms of x? So we are very familiar in terms of x. So I am just going to replace the y value in terms of x. What is the y value? So how do you get the y value? So to replace the y value, already radius is there. With the help of the radius we can replace by the Pythagoras theorem. By the Pythagoras theorem. What is the Pythagoras theorem? Total. It is a diagonal. So it is a right angle triangle. Yes. In this right angle triangle, what is the hypotenuse? So x square plus y square is equal to hypotenuse. That means 2r whole square. So from this we can easily get y square is equal. We are interested to replace the y value, so that y square is equal to 4r square minus x square. Y is equal to positive square root of 4r square minus x square. Replace this y into here. So area only in terms of x is x into positive square root of 4r square minus x square. Now observe that area only in terms of x. Now this function we have to maximize it. Maximize the area. So maximize this function. How to maximize this function? So use the second derivative test. That's all. Are you clear? In a pixel circle, rectangles are there. Out of all the rectangle, the square has the maximum area. I just taken a square. Here we are not supposed to take x square because square length into breadth both are same. Don't take it because rectangles are there. Rectangle has the maximum area. When it is, whenever it is a square, whenever it is a x is equal to y, that one only we have to get it. Okay. So here area in terms of only x is the. Use the second derivative test, get it a double dash of x is positive or negative. Here is maximum is that a double dash of x at the critical point should be get it as a negative. So differentiating once a dash of x is equal to x differentiation 1 root of 4r square minus x square plus and root of x as it is x as it is square root x differentiation is 1 by 2 into root of x, 1 by 2 into root of 4r square minus x square. In place of x, 4r square minus x square. What is the differentiation of 4r square minus x square? Minus 2x. This is 0 minus 2x. Here 2 get cancelled. So a dash of x is equal to, I am just going to rewrite x into minus x. Better try one more step. 4r square minus x square. Here it is a minus x into x square divided by root of 4r square minus x square. Take LCM as a root of 4r square minus x square. Root x into root x is x. So it becomes 4r square minus x square. This minus x square as it is divided by root of 4r square minus x square. This is the a dash of x. Now again I just continue here. So suppose a minus x square, what happens? Minus 2x square. So 4r square minus 2x square divided by root of 4r square minus x square is that. Now we can take the 2 is common. So a dash of x is equal to 2 into taken common. What happens? 2 into r square minus x square divided by square root of 4r square minus x square. Now again differentiating this one, or else here only we can find the critical point. Suppose a dash of x is equal to 0. If a dash of x becomes a 0, what happens? This whole term is equal to the 0. This is 0 into the whole term is reduced. What is left? 2 into 2r square minus x square is equal to 0. How it comes? This value is equal to 0. This is equal to 0. What happens? Cross multiply 0 into that number, get eliminated, then only numerator value is left. 2 is never becomes a 0, so that 2r square minus x square is equal to 0. From this we can say that x square is equal to 2r square, or else x is equal to positive square root of 2 into r. This is the required x value. I just consider only the positive value because length of the rectangle is never becomes a negative quantity. So that reason I just written a positive square. Now again this equation star is again differentiating. So to get the a double dash of x, again differentiating the equation number star with respect to x, what happens? A double dash of x is equal to a double dash of x is equal to what? You can use the quotient rule. How do you use the quotient rule? By p equal dash is equal to u dash p minus u into p dash divided by p square. I just take the 2 is outside, 2 is product with this term outside, 2 numerator function differentiation u dash differentiation is r is a constant, fixed radius is that r is a constant, it is a minus 2x into p radius root of 4r square minus x square minus u dash into p minus u into p dash, u value is what? 2r square minus x square, 2r square minus x square, u into p dash. What is the p dash? Root of 4r square minus x square. What is the root x differentiation? 1 by 2 into root of 4r square minus x square. In place of x, 4r square minus x square differentiation is minus 2x into minus 2x. This whole thing divided by p square. P square is nothing but root of 4r square minus x square whole square. That is only we can write as a 4r square minus x square. Now simplify. Here 2 get cancelled. Already 2 is. This 2 I just kept outside. Okay. This 2 as is. Now take LCM. What is LCM? Root of 4r square minus x square. Here is root of 4r square minus x square is that. Get cancelled. Only thing 4r square minus x square. Why? Because root x into root x is a x. Minus. Here minus. It becomes a plus. 2r square minus x square into x. Whole thing divided by this LCM term taken to the denominator. 4r square minus x square into 4r square minus x square. Now this is our a double dash of x. We can again simplify this one. Open the bracket and simplify. We will get the simplified form, or keep as this. Once again check it. We have to replace the x value. Okay, we can easily decide whether it is a positive quantity or negative quantity. At this moment, no need to simplify further. To how much we can simplify, because not necessary, because x square value is there. You can directly replace it here. If you open the bracket x into x cube, again we will need to consume the time. So that reason keep as it is. Now find the second derivative test at x is equal to root 2 times of r. R is, you can say that x square is equal to 2r. X square is equal to r square. What happens? Wherever x square is there, replace it to r square. Wherever x is there, root 2 into r. So that a double dash of x at x is equal to root 2 times of r is equal to 2 into. Our aim is to get whether this quantity is a positive or negative. That's all. Minus 2 into x value is what? Root 2 into 4r square as it is 4r square x square. What is the x square value? X square value is 2r square plus 2r square. X square value is 2r square. 2r square minus 2r square. This whole term is cancelled. This is 0 divided by 4r square minus x square. Root of 4r square as it is. R square is 2r square. Sorry, x square is 2r square into 4r square as it is minus x square is 2r square. Simplify. This is minus 2 into root 2 into r. This is 4r square minus 2r square is 2r square. Whole thing divided by root of 4r square minus 2r square under the root of 2 times of r square. That we can write as a root 2 into r. Only we can write as a root 2 into r. Clear? The root of 4r square minus 2r square is that. This is the root of 2r square. Root 2 into root of r square. Root of r square value is r. 4r square minus 2r square is that. This is x square. 4r square minus 2r square. What is the value? 2 times of r square. Are you clear? Okay. Now this 2r square get cancelled. Root 2 into r get cancelled. What is that? 2 into minus 2. This is the minus value. So a double dash of x. What is a double dash of x? Minus 4. Minus 4 is nothing but a negative quantity. It is a negative quantity, but what happens? X is equal to root 2 into r is the point of maximum or minimum. It is the point of maximum value. Why it is? Because of the second derivative test. It is the point of maximum. Therefore, we got it. So x is equal to root 2 into r. What about the y value? If the side length of the rectangle is root 2 into r, what about the y value? How do you get the y value? Here it is that. So from this, what will get the y value? Y is equal to root of 4r square minus x square value. What is the x square value? X square value is 2r square. Simplify. Root of 4r square minus 2r square. This is the 2r square. Y is equal to root 2 into r. So observe that whether x is equal to y. What is that? X and y? Root 2 into r. Therefore, x and y must be equal to get the maximum area of the rectangle. Rectangle has the maximum area when both the sides are equal. Length and breadth are equal. Length and breadth are equal means obviously we got the square. So that in a fixed circle, rectangle has maximum area whenever it is a square. Very important result. This result directly they might ask in the CET. So they used to give the result. What is that? Or else the rectangle inscribed in a fixed circle has the maximum area. Then what is the side length of the square? Rectangle or square has the maximum area inscribed in a fixed circle. Then what is the side length of the square? The side length of the square is root 2 times of r. Very important result. So just remember, or else you just know the process to find that how to get or how to use the maximum and the minimum or second derivative test. Now next problem is a man of height 2 meters walks at a uniform speed of 5 km per hour away from a lamp post which is 6 meter high. A lamp is posted at 6 meters height. Find the rate at which the length of this shadow is increased. Okay. Here lamp is of the height 6 meters and man of height 2 meters. Suppose here is a man. The height of the man is 2 meters. This height of the man is 2 meters. The lamp is that the lamp light or lamp is fixed. What is the height? It is in the height of 6 meters. Lamp height is 6 meters. Man height is 2 meters. A man of height 2 meters walks at the uniform speed of 5 kilometers. He is walking on the right hand side or left hand side. Away from the lamp. Lamp is here. Away from the lamp. In this direction, a man is walking. So that is nothing but what is the rate? Rate of it is increasing. So it is a 5 kilometer per hour. The man is walking 5 kilometer per hour. Then away from the lamp. In this direction, he is moving. So that we have to take this is the rate of change. Which is a 6 meters of lamp height. Find the rate at which the length of his shadow is increasing. So here man is moving outwards the lamp, so that a shadow is here. Here is shadow of the man. I just call it as a small s. And S is the shadow length, and I just denote it as a L length of how much is far from the lamp, bottom of the lamp. So I just name that AP is the height of the lamp and CD is the height of the man. I just call it as the E. So here one triangle will get. So actually two triangles ABE and the CBE. Two triangles are there. So according to the words, a lamp is fixed at the height of 6 meters. A man of height 2 meters walking away from the land at the rate of 5 km per hour, then the shadow of the man is increasing. In which rate it is increasing? I have already taken this length is s in it, so that means we need to find that ds by dt with respect to the time. ds by dt is equal to how much? So what they have given? They have given the dl by dt. What is the dl by dt? 5 kilometer per hour is that. So that 5 kilometer per hour is that. That's why I just taken a ds by dt with respect to the time. Before that, we need to write that let. What is that? Let. L is denotes that. L is the length of the man is of the distance of L units from the lamp. L is denotes the length is distance away from the lamp, and S denotes the shadow of the man. And AB is equal to 6 meters. CD is equal to 2 meters. This is the height of the lamp. This is the height of the person. Okay. Now, how do you find that the shadow rate of change of increase or decrease? Obviously it is increase. It is actually comes to the increasing rate measure topic. Now one problem is left, so that reason I am just discussing at this moment here. Okay, now what is the rate of change of the shadow of the man? So how to find that rate of change of the shadow of the person? Here two triangles are there. There are similar. What are the two triangles? The triangle ABE is similar to the triangle CD. Do you agree? These two triangles are similar. They have the same property. Similar triangles already know that. The same and the same property is that. So these triangles are similar. So in such case, I just take the ratio, that is AB divided by CD. AB divided by CD is equal to AB divided by CD. They have given height, and we need to find the ds by dt. So that I just take it as a AE divided by C. AE divided by C. In a triangle ABE, AE divided by C. Do you know the AE value? You don't know, but we can get it. AC plus C. How do you get the AC plus C? AC is nothing but L. C is nothing but S. So that what is the AB? AB is 6 meters. What is the CD? 2 meters. And AE whole length we don't know, but we can write it as a L plus S. Already we just chosen L and the S divided by. What is the CE? CE is nothing but only the S. Simplify, cross multiply and simplify. So what we get? So 2 1s are 2 3s are. Cross multiply 3 into S is equal to L plus S. S taken to left hand side. 2 times of S is equal to L. S denotes the shadow of the man. L denotes the length away from the lamp. Man is L denotes away from the lamp or bottom of the lamp. Now differentiating this value with respect to what? With respect to the time. So 3 times of ds by dt is equal to dl by dt. What we need? We need the ds by dt, so that 3 times of ds by dt is equal. Have they given a dl by dt? Yes, the dl by dt is given. How much? 5 kilometer per hour. Now the required ds by dt is equal to, what is the required ds by dt? 5 by 3 kilometer per hour. So this is the rate of increase of the shadow of the person. Rate of increase of the shadow of the person of the lamp is 6 meter height, and the man having the 2 meter height is 5 by 3 kilometer per hour. It is positive quantity, so that it is increasing. Just get the, now got the required answer. So this is the problem on the rate measure, first exercise. So this completes your application of derivatives, all the application. So what are the application you have just studied? Approximations, tangent normals, rate measures, increasing, decreasing, and the maxima and the minimum. These are the 5 applications of the derivatives are there for your second PUC syllabus. All the exercise and some problems, different models of the problem I have already solved in the previous videos. The remaining problems of the exercise and solved exams are left to you. Okay, so better to solve those problems and maintain a single goal, because you are going to write the examination on preparation. You have to take the reference of those notes only. So better to maintain a proper notes and solve all the problems with respect to that problem or with respect to the respective exercise. So okay, now it completes the application of derivatives. In our next video we'll continue the new chapter, okay, another chapter of the second PUC NCERT book. Okay, thank you.